Hello and welcome on today's webinar. Okay, I still can see some attendees are joining, but okay, I think I can introduce myself first. So my name is Michał Oleksy. I work as an application engineer at SDC Verifier, and today I would like to present a webinar about structural compliance for extreme and non-standard loads in defense industry. Okay, so I see we have probably already most of the attendees. So let's start. I think we will proceed with presentation, and at the end of the webinar, we will have some time for questions and answers. In the meantime, if you have any questions, please drop it to our chat, and we will review them at the end of the session. Thank you. Okay, you should be able to see my screen. So let's start. First of all, we will discuss today the context about the non-standard and extreme loads, which we can meet in during analysis of of defense and military structures. We will speak about nature of these loads and what are the differences between the regular loads and the regular condition, which should be analyzed during the FEM calculation. And also we will speak about compliance challenges in defense programs. So what engineers can struggle with during the calculations, what are the general requirements of defense industry, and also how to deal with it. So that's the most important question. I will also show you how SDC can help you with that. So what we can do, what solution we developed in order to help engineer and make your process smoother and first of all much faster and more accurate. And at the end, we can have a short discussion with answers. So I suggest if you have any questions, please drop them into the chat. Just a few words about our company for some people who are here for the first time and doesn't know SDC Verifier yet. So we are an international company with headquarters in Netherlands and also Poland, where I'm located, and western part of Ukraine. We are on the market since 1998, where SDC started first at the consultancy service and then later on started developing also software, first of all for our own needs, but then at some point it started to be software which can be help also for other companies. At the moment, we have more than 40 team members. We did more than 300 consultancy projects in, I think, last 5 years. More than 1,000 happy users. So as you can see, the numbers are increasing and increasing every year. And at the moment, we have also 5 software products, which we will discuss slightly later on. Okay, so let's start. So first of all, why extreme and non-standard load cases dominate that military industry and defense design? First of all, operational environments are unpredictable. So combat, emergency maneuvers, blast effect, and harsh climates can create loading conditions way beyond typical civil or commercial designs. I think it's understandable. Then mission-driven design requirements. So depending on the function, the equipment must remain functional. Often the requirements says that even after impact or some shock, the equipment has to be still in use, even with some partial damage. So that these are all the cases which are to be taken into account in order to mission to be able to continue. All these loads usually have low probability of happening, but very high consequences. So even rare loads like crash or blast or fire, load firing, some transport drops must be considered, because failure in this case can lead to loss of the critical equipment or even to loss of life. And another thing is that the often platform used for military and defense solutions have to be multi-role. So defense systems often operate in multiple configurations. So we don't only take into account one way or one scenario how this platform or part will operate, but there might be different configurations which will result in different load combinations, some individual requirements for certain part, which are often difficult to standardize. What are the expectations in safety critical programs? So first of all, strict regulatory and military standards define that the structures, parts, or the whole mechanism should be compliant with some standards like NATO standards or certain standards depending on the location, as well as naval authorities, if we speak about naval structures, or some customer-specific criteria, which can be very different depending on the manufacturing company, depending on the country, depending on the missions, also the solution. The next thing, which is crucial also in design of all the military structures, are the traceability and verification of the structure. So every structural requirement must be linked to the analysis. So testing and analysis should be documented, and evidence needs to be always demonstrated. So there is always need to prepare a lot of accurate documentation for each of the structure. Also, taking into account all the non-standard loads, engineers and requirements are always usually prescribe the conservative design philosophy. So much higher safety factors than typical structure, redundancy and damage tolerance requirements. So all these things compared to commercial products are much more restrictive. And often independent review and certification is required. So again, we have to have our good documentation of our of calculation and the approaches in order to allow for independent review and decrease the questions after that. Another thing is life cycle responsibility. So compliance extends beyond design to manufacturing quality and inspections, maintenance, and in-service monitoring. So we will try to understand the nature of extreme loads. First of all, identify typical sources and how they differ from conventional and structural designs. Also, try to review how we can comply with this expectation by the verification with use of FEA software, and also how we can approach the results and how to combine all those complex load cases into something which can be actually verified and stated whether this structure meets the requirements or no. So there is one thing which is the output of analysis, and then another thing where we actually need to know if our structure will comply, will be safe enough, and whether it will withstand all the loads. Okay, so let's go on. What is the nature of extreme and non-standard loads? So first of all, the exposure to so these forces, these non-standard loads, are often rapid change of force, of pressure, and are unpredictable. So nowadays it's hard to even often specify the load, the direction of the load, as there are new different impact cases, different weapons, which may result in different loading scenarios. As we already said, these loads often exceed commercial and civil designs, and they should be focused on the real operations scenarios. So these real operations, often the experience from operations will result in assumptions for the loading. Here on this picture, you can see, for example, the load, which is the impact of some explosion under a light armored vehicle, and the difference of the impact between which result so the shape of the bottom of the hull of this armored vehicle has a huge impact in this case, for example. So these are also the things which should be taken into account while analyzing the loads. Extreme loads have often very high magnitude and very short duration. We can outline here loads like shock, blast, impact, or some emergency maneuvers, where often the direction of the load is hard to predict. Also, often analyzing these loads require nonlinear approaches, require very complex analysis and complex load combinations. Okay. Another thing, as we already said, are the combinations of these loads. So out of all of these different cases, different loads, including some blast loads, but also some extreme terrain conditions or extreme thermal stresses, they often act together with another condition. So all of these cases needs to be also taken into account. Another thing is that often these different cases should be taken with different safety factors, which may result in hundreds, even thousands of different load combinations, taking into account different purposes of the equipment. So this is for sure the challenge of the engineer, how to interact all this effect in one analysis and get one solid answer whether the calculation was right. And for sure, single load analysis may underestimate the risk. So that's the only way to comply should be to combine all these extreme cases together. Another type of loads would be transient and asymmetric loads, where again, transient load we have rapid change of magnitude or direction. So, for example, launch events or weapon firing, hard landings, in case of some parachute, or dropping of the load. And asymmetric loads where the force distribution across the structure will be uneven, so some rotation, torsion, and so on. Where for example, uneven terrain, depending where if some part of vehicle is designed to move on uneven terrain, that can cause some extreme load scenarios. And here again, combination factors may vary, which will lead also to some local stress concentration with, and as you know, these structures used for defense military should have much longer life cycle than the average structure, and also stress differences, delta stresses taken for fatigue calculations will be much greater in these cases. So this also should be taken into account, not only the blast or loads which can occur, but also these long-term loads which act on the structure for a whole period of working time. Here in the reality of defense system, all these operation environments can vary very widely. So the structure can be designed to operate in the very cold condition, Arctic snow, or in sand of the desert, or for example rainforest. So all of these environmental conditions will have different impact on the structure. So that's also something which should be taken into account. Fuel state, so the type, the amount of fuel which we have in the tank, and intensity of maneuver, attitude, speed for driven objects, and also for floating or for example some drones. So why standard load assumptions are often not sufficient in this case? So as we discussed, this simplified average conditions, which are used by standard assumptions, often are not sufficient because they don't take into account all these cases which we have discussed. They may not account for some combined extreme loads, which are often based on the mission requirements, or on the specific requirements for certain vehicle or a naval object. And it's hard to gather all the battlefield or emergency scenarios in one standard. There is many things which can happen, and we see it every time on the battlefield. And here consequences may be serious. So failure of an part, which may lead to excluding the structure from the battlefield, or even loss of lives. Here, the best practices would be to use scenario-based analysis and simulation. So taking also experience from another structure which already operates, and try to simulate these loads as accurate as possible. And if possible, validate them also with testings. So all these all these assumptions should be taken as a conservative margins. Let's move on to compliance in defense. So, yeah, as you can see, it's more than just checking a box. We need to meet different multi-layered regulatory environments. So, for example, not only the requirements from the, let's say, typical standards, in case here in this example for naval structure, so such as ADS, DNV, or any other standard, but often they should be taken into account together with requirements from standards such as STANAG, which is used in NATO, or UFC, which is used in US structures. So all of these requirements combined together result in strict verification and validation expectations. As we already said, all of this should be always documented and clear for some second-party reviews and for ease of modification later on, even during the during the next stages of the structure. Often there is one base for the structure which is designed once, and then the purpose of it will change after a certain time, after a couple of years. So this documentation is always needed there to verify, and the life cycle is much longer than unusual structures. Okay, so how to translate these load cases into something which is possible to verify? So for sure, all of these different types of analysis, so for example, it can be, if we speak, for example, about ANSYS, some transient analysis, so LS-DYNA outputs, simple static or different nonlinear outputs, how to combine them together. So that's something which bothers engineers. Of course, it can be done manually, but yeah, there are much better ways to do that. I will show it in a while. So also, even if we have our results ready, so we have stresses, we have some displacement, it doesn't mean that we already have an answer that the structure is actually safe enough to operate it, that meets the standards, the mechanical standards, and also specific standards for which are military standards. So here, typical gaps are that model assumptions are not aligned with the certification basis. So we always need to be sure that our model actually represents what we need to analyze. And another thing, incomplete load combination. So if we miss something in our loading load combinations, then the answer is basically wrong. So we're never sure whether the structure is designed properly. And here the verification methods, of course, we are focusing on FEA, but often dynamic testing, physical testing, all are also used in conjunction with FEA in case for example, some materials which are not well known, which results at the end in some hybrid validation process. Few more words about safety factors. So here it is also very important to have safety factors assigned in a correct way to different parts of the structure, as this may vary. That may be a case where different parts of structure should be taken into account with different risk factors or safety factors. And by assigning them in a wrong way, that may result to under protection into critical zone, weight escalation, which is also not the best if we want to produce the structure often, if it's designed once, we produce it in multiple, in bigger amounts. So all of this will change the cost of manufacturing, and also it can be under-protected or over-designed. So there are two things which we need to take into account. And as we discussed before, often defense programs require the analysis, tests, and it should be all linked together. The version control documentation, where reports are clearly marked with different numbers of version to track all the changes, and the traceability requirements must show which loads drove the design feature. So, for example, which load gives the governing stress or displacement. So, which is actually the cause of why design is in this way. So how to clearly show it in the verification. Okay, and here, what can be the cause if we miss something? So of course, structural redesign in military is much more expensive than in typical commercial structures. Their whole process is much longer, or the certification or the validation. This requires much larger amount of people, of engineers, of different certificates. So all of this, every time you need to redesign something, this increases the analysis time significantly, as well as the calculation cost. And so here, the FEA and all the assumptions should be clear ideally from the first iteration of calculation. Okay, let's then speak about solutions. So how SDC Verifier fits into this topic, and how actually SDC Verifier can help you with that. So what actually is SDC Verifier? SDC Verifier is a software which works both as an extension to popular FEA software such as ANSYS, FEMAP, or SimCenter, or it can be also separate standalone software with graphical interface, Nastran solver inside, and all the possibilities. Doesn't matter whether it's extension or standalone software, you always follow the same let's say cycle or workflow, where engineers start with simulation. So the model has to be prepared with all the boundary conditions, loads, as we discussed. Later on, SDC will help you significantly decrease the load combination time, which will allow you also to do linear combinations, excluding your solver, whether it's ANSYS or Nastran. All these linear combinations can be done directly in SDC, which decreases the calculation time significantly. Of course, if we speak about linear outputs, but non-linear output sets can be also combined, but not with use of factors, because that then it's obviously not the case. Another thing where SDC helps you is the recognition. So what does it mean? After your model is prepared, you get the stress results. Engineer actually needs to validate different structural parts, such as welds, panels for plate backlink, fatigue for welds, for non-welded parts. So the recognition allows you to automatically recognize these different structural parts out of your FEA model. Then checks, so the database of all the checks such as ABS, DNV checks, they are included inside SDC and can be used. A part of that, user is also able to create own standards, and this is very important in military industry because here many of companies of offices use own requirements, which often are based on typical checks because let's say mechanical engineering is the same, the physics is the same, it's just mostly the difference is the approaches or safety factors or maybe some extra checks which should be performed. So all of these extra requirements can be created by yourself, added to the software, and protected by password. So only you or your company have an access to this way of creating of checking the structure, and all of this can be automatized. Another thing is the optimization. So here you are able to optimize your welds, your plates against plate buckling checks, or for example beams of some lattice structure. And one of the most important is reporting. So automatically created document which can be easily updated even after iteration in the model. One button generate can update all of your plots or of your tables. You can include also all types of explanation about the standards, about the factors which are taken into account, governing loads, and so on. So all of this I will explain now in details. Yeah, as I said, SDC works for for ANSYS, where it can directly connect with your mechanical. It can read your stresses or the model parameters and allow to plot directly the results again into your ANSYS graphical interface. One thing which is fairly new in SDC, it works also with LS-DYNA, so you can also read all the results from LS-DYNA, post-process them with SDC, and do the checks again against those results. As I said, we have also a standalone version, which includes graphical interface, possibility to create the model, verify it, calculate it with NAS solver, and do all other workflow which SDC allows, so do the checks. And a part of ANSYS, we work also with SimCenter and with FIMAP. As I said, you have possibility to create geometry, meshing, apply all the loads, and use SimCenter NAS solver, and at final stage create automatic reporting. SDC also allows you to create some specific loads, which, depending on the platform, the loads will vary slightly, but in general, we have possibility to create wave, buoyancy load on your structure in automatic wave, also wind or wave loads taken into account, also drag coefficients, wind drag coefficients, which for some of the standards can be also created automatically based on the geometry of your model. So that's also something which significantly decreases the load application time and also makes your life easier. The next step, as we were discussing, were the load combinations. So in SDC, you are able to combine different analyses. So for example, let's speak about ANSYS. You can have LS-DYNA output. You might have some typical loads calculated by in simple static structural. Then you might have some transient analysis with or some vibrations and so on. So you can import all of these results in SDC. Well, it will be even done automatically. And then you can create your own envelopes of the results even in one picture for all of these conditions. So it's much easier to verify your structure against different standards. You don't need to do it separately, extracting some forces separately for different scenarios. You can combine as many scenarios as you like into one SDC project, create load sets, apply different safety factors. So as you can see here, you can create the matrix with different safety factors, which will result in different load combinations. And as I said, for example, if we speak about ANSYS again, changing these safety factors or creating new load combinations does not require you to recalculate your ANSYS model. So that's something which decreases the calculation time significantly. Automatic detection. So you're able to detect automatically joints, beam members, panels for panel plate buckling in naval structures, welds, which can be used in fatigue calculation or simple weld strength checks. How does it look like? So out of your structure, you are able to, with one click, to recognize and outline all the beams, panels, so whether it's on armored vehicle or even some other floating structures. SDC allows you to automatically recognize and read all the parameters of these parts, such as a weld length, type of the weld. Here, the weld does not need to be modeled, so SDC reads the connections between the plates. And this is the basis for all the checks which later on you will create and you will add to your project. Here I have also example, for example, for naval structures, some ship, how SDC recognizes different plates. So it can recognize sections along, across the ship hull. The sections are divided into the panels on all the intersections and also into the plates wherever stiffeners are modeled. So that's also all the detail is picked up automatically. And as I said, it works, it can be sorted by different planes, so decks, horizontal or vertical planes can be sorted out. It works well also with curved structures. We have also standards which allow you to check curved backing plate backing for curved panels. So all of these checks you can do directly within one software. Here about the weld recognition. So SDC, as I said, recognizes all the intersection of the plates, changes in directions or thicknesses, which allows you to recognize even such a big amount of welds as you can find in ship structure or some other structure like that. Yeah, the next thing which also is important in all of the military structure is to pick up all the even tiny detail which has some overshoots which may lead to failure later on. So with SDC, you have also possibility to use tools such as Peak Finder, which will allow you to quickly find the let's say the zone where your results exceeded the value which you actually selected as a maximum. So even in a huge model with lots of elements, lots of plates, beams, it's fairly easy to find the zone which is interesting for you, which may fail. Okay, another thing is that all the standards which is in SDC allows you to modify the input. So there are different approaches. So for example, if we speak about plate buckling checks, you may choose whether you want to see average elemental stresses, minimum midplane, or just elemental stresses. So this is just to outline that there is many possibilities of the result output you may preview. Here as an example, some results of DNV and ABS buckling checks. So you can also sort these results by different sections, group them. That makes also life much easier for the reporting. So all of these results can be sorted out with different chapters. And as the requirement says, all of these steps which were taken in order to obtain this result will be prescribed in one document. Here also another thing which is obviously important, taking into account non-standard loads, as we discussed, which may result in much higher delta stresses, which again may result in very high probability of fatigue, is that with SDC you are able to check the fatigue of your structure in much quicker way than manually. It can be done very quickly by assigning the classes for different welds, and later on obtaining the results, taking into account all these notch or SN curves, the classes, well, different names depending on the standard, but at the end of the day, you are able to create your stress history, analyze it with number of cycles, predict the number of cycles, and then get the results for every part of your structure. One more thing, which is, as we discussed before, is very important, is to know which load case is actually governing for which part of your structure. So here you can see, you can create also this type of plots and see, okay, for example, some sort of asymmetric load will be the highest in this zone. So you can see your model colored with different colors, which shows which load and which load set creates the highest result in this case. This can be done for stresses, this can be done for result output checks or utilization factors. As I said before, you have also possibility to perform optimization of your model. So to optimize the plates, optimize weld sizes, beam sizes or stiffener sizes, as well as thicknesses of the plates, depending on the results. SDC at the moment has more than 55 engineering standards implemented. They are split into different groups like bolt checks, beam checks, fatigue checks, or buckling checks. So as you can see, there are quite a lot of different certification societies. But a part of that, as I said before, you are able to create also your own standard certification procedure, well, non-standard certification procedure, save it, protect it with password, and then use it in the same way to automate your verification. So you can transfer spreadsheets, which you have at the moment, easily into SDC with use of all these variables, and in this way automate your verification. This standard which you create is stored on your computer. It's password protected or inside your web. It depends on the security levels you have, but no one has an access to this, except of the person who is allowed by the creator. SDC supports certification and engineering decision by helping you to create the traceable reports where you can show the evidence how everything is calculated, what assumptions are done, also how model is created. So all the information about the model, materials, factors can be included in one report. And here, the important thing is that all these results must be clear and easily reviewable. So with SDC, you are able to create this template or use any template which is ready-made. Of course, it can be adjusted up to your needs. And the best thing is that if you change something, you have some iterations, you simply can regenerate the views, and all the views or the tables, output sets will change automatically. So you have always track of what was changed. You can make different versions of the reports, store all of them in one place, and it is always easily accessible. Few statistics based on the experience and on our customers. So with SDC, you can save even up to 80% on post-processing and on working with standards and reporting, which I think is significant amount of time, taking into account that most of this work, let's be honest, for most of the engineer, reporting or verification often is pain, and if you can speed it up in anyhow, that's something which you should do, and then let the engineer do engineering job. So think about the solution, not waste time to make a screenshot or update formulas in Excel and so on. So here you are always sure that standards are updated, and your report is updated, and there are no mistakes because it's generated automatically. So you don't miss any update or any value, which, here in this case, in military industry, this is crucial to have accurate results. So, summarizing, verification directly on popular CAE softwares. So from our experience, defense companies often use ANSYS software, but also Siemens and Nastran softwares. But here SDC covers all of this. You are able to post-process and to verify results, which, doesn't matter whether it's transient or LS-DYNA outputs or simple static. You can do all of this directly within your CAE software, so you don't need to merge your model or move it to another software. All the checks can be done directly, so bolt, fatigue, buckling, strength checks within one software. Again, no need to jump between different solutions. All of this is included. Standards, more than 55 at the moment, and you have possibility to add your own ones. And all the calculation is consistent. So this is something very important. So you have always track what was done and what was calculated. SDC is transparent, so you are able to preview all the formulas, everything which was calculated. It's not a black box. So this is very important if you need to know what was the path of calculation. And automatic documentation. I think here this is clear. Here are also some customers, chosen customers. We have more than 200 around the world. Here are some, mostly from I think from naval structures, but just for your information also, who trusted us. Yes. Thank you for your attention. I hope this was informative for you. Please drop any questions into the chat. I know can be slight delay in the webinar platform, so I will wait a couple of seconds, and I will try to answer them. Okay, I can see some questions. So transient load and impact loads, how can we analyze these loads on paper first? Okay, well, it can be hard to do it on paper with some complex structure. I would say we can always try to schedule some call for that and try to discuss it separately. I think that's a good solution. Okay, I see. Next question. When it comes to unpredictable loads that may go beyond acceptance criteria, with reference to loading conditions where the design pass-fail criteria was set up to be linear yield point, such as the exceptional load input magnitude is elevated by a factor, for example, 3g. That takes care of energy absorbed by the nonlinear behavior. If the unpredictable exceptional load result in stress strain go beyond yield, are there any standards available in SDC Verifier to estimate the elastic backing limit of the structure with beams loaded in axial direction, explicitly using just the FEM? No results. What happens after elastic backing? SDC, SDC standalone has simple linear backing analysis, so that's one thing. And we will speak about SDC for ANSYS or for FEMAP, then we post-process the results. So here we can here we can calculate the backing results based on the standard. So yeah, depending on the standard, there are different formulas, of course, but this is the workflow which can be done with SDC. Does SDC Verifier have capability to import ANSYS LSDyna input and output files now, or is it being developed? SDC connects to LSDyna, so it will read the inputs directly from ANSYS. So you don't need to import it to SDC. It will read it simply from ANSYS LSDyna, same as from simple static structure in mechanical, for example. So you can post-process them, and it's already available. Extreme loads often go hand in hand with plastic strains. Can SDC deal with those? SDC can read all the outputs, whether it's strains or any other output from, for example, from ANSYS. So you can post-process them also as you like. That's also something you can do. Okay. MIL STD is baseline for testing military products. Is there any idea to implement these cases test conditions? At the moment, we don't have this standard, but you can, of course, try to implement it, or we can help you with that. Try to implement with SDC logic. So all these conditions which are prescribed there. Well, I don't have these conditions in my head for at the moment, but I think this should be possible because all the procedures can be calculation procedures can be implemented, or some conditions which should be met. Is this software for free? We have a free trial. If any of the attendees would like to try, I'm not sure if there is my colleague, but I would ask to drop the link to download or register for the free trial. So please follow this link. I hope my colleague will be able to do that in the chat. Okay, let's. I don't see any other questions. Let's wait maybe a couple of seconds because of the chat delay. Of course, if any of the attendees would like to discuss further or more in details your doubts and your concerns, please contact us. You can contact me directly by the email you can see on the screen. You can contact us via SDC Verifier website, book a demo, and we can discuss approach, your approach. We can discuss your troubles, concerns, and try to find the solutions. So feel free to contact us. Okay, thank you very much then. I don't see any other questions, so let's finalize. Thank you very much for attention, for all the attendees who registered. The recording of the webinar will be also available on the YouTube platform. I see one more question. Are there any specific standards for laser welding assessment? Here, we don't have any specific requirements, but I think the typical welding standards also should cover this. Okay, thank you very much. Let's stay in touch. Bye bye.